Hi everyone, MickMake Mail number 21. I've got something from Kogan, which is a bit big. Something from FedEx, I don't know where it's from. And also I've got a bit of a helping hand. Come on, say hello. Oh, I guess he's a bit shy. Alright, so let's get stuck into it. I'll leave the Kogan one for later, and I'll look at this one. Now, all I need is some scissors. So I have no idea where my second scissors are. Oh, thanks, second hand. Excellent. So, alright, let's get stuck into this. Ah, fantastic. Okay, so this is the IkaScope. So the IkaScope was in one of my weekly roundups, and this is it. So it's a Wi-Fi based scope. It has 200 megasamples per second, giving you 30 megahertz analog bandwidth, plus and minus 40 volt input range, 100 millivolt to 10 volt per division. It's got a 10 mega ohm or 14 picofarad input impedance. It's an 8-bit sample resolution, so not as extreme as some. It has 4,000 sample points inside. It's got a 420 milliamp hour battery, which they claim gives you an uptime of about 1 week with daily use. And pretty much every single operating system is supported. Windows, Linux, Mac, iOS, Android. Unfortunately, there's no FreeBSD, so sorry guys. But let's give this a whirl and see how it goes. Now, unfortunately, there's no Android app yet for the IkaScope, but there's one going to be released soon on the 13th of November. There is, of course, the iOS app, so just getting that. So plugging it in for the first time, of course you need to plug it in to charge it up. I'm assuming that this light means that it's charging, and I'm also assuming that the light will go green when it's finished. Okay, so you've got to turn it on by pressing this button here, and it should buzz and you should see the little white light flash. So let's see if we can see it on the network. So I wrote a little bit of code on a Arduino, and all you have to do is just push the probe down and you should start seeing a nice little waveform, and that's pretty good. For as long as you hold it down, of course it will just keep displaying. You can stop and zoom in onto that, so that's pretty decent. So the output I'm generating here is an oscillating PWM output, and from, I think it's toggling at 16 megahertz, I think. So you can see, zooming in, you can start to see a lot of the ringing that goes on with these pulses, so that's pretty decent. When you start to get down to sort of nanosecond resolution, you start to see where the scope sort of chops off. This is down to 20 nanoseconds per division, and really most of the stuff you do, unless you're dealing with sort of gigahertz frequencies, most of the stuff you're doing for this sort of thing that's more than adequate. So IkaScope have made available Windows, Linux, OS X, iOS. Unfortunately there's no Android yet, as I mentioned before. So let's try the Mac OS version and see what it looks like. Yep, okay. For some reason the OS X version doesn't seem to work. So one of the things they suggest doing is connecting your IkaScope directly to a network. So you access it from, once you're in here, you access it from this little button. Then you can add a network, and of course it lists up the SSIDs and you can connect directly to it, which is nice. So once you've managed to connect it to your Wi-Fi access point, you can start it up. It'll just connect and it'll turn blue, or it should turn blue, and you probably can't see it, but it is actually blue. And then I can just connect to a device on my iPhone, and you can see it's come up as STA mode, just connect to it. So once you've got it all connected up, we can just see the original waveform. There we go, and you'll notice it's actually a lot faster than before. You can zoom in on the scale a bit. Maybe move it down. In fact, I might click on auto set, which is a nice feature of most Crows. And there we go, we've got a nice waveform. So this is in STA mode, which is a lot faster, they claim. And I'm actually really liking this. This is a really nice tool. I'm actually quite enjoying it. So I thought I'd try it on a my iPad. It's a very old iPad. I haven't upgraded for some years. So let's try and connect. And you just presented with the same interface. There we go, look at that. So zooming in on the iPad, we can actually see the ringing going on. I thought it was going to be a bit cheap and nasty, but I'm actually quite impressed with it. So I managed to pull it apart. It was a little bit difficult. There's a few points where it's actually super glued in. So you've got this point here which super glues into that little point there, and this point here which glues into there. The tip supposedly can be changed, but you need to pull apart the whole thing. In terms of the goodies, of course you've got the LiPo. You could probably fit your own larger LiPo if you wanted a longer battery life. So it's based on an ESP32 and a couple of other analog bits and pieces. That's a Worth push-pull transformer, a couple of op amps, and so forth. So it's fairly basic, not much to it. I'll certainly take some close-up photos of these and put them up on my website, so you'll be able to see exactly what all the chips are. That's about the insides of it. It's pretty simple, really. In terms of repairing it yourself, you could actually do it. So if this button does wear out, you could very easily take this out and replace the button. So it's not too hard to do. The main problem is just getting past these 2 points here where they're glued in to the bottom side of the plastic. So what do I think of it? The probe tip has a fairly nice solid feel to it. So it lets you know that it started acquisition. It would have been good to add some buttons down the side here to set things like resolution, time base, things like that. You of course only have the one input, so you can't do external triggering, which sort of limits the use cases for it. What else? Of course, running off battery and using Wi-Fi connectivity. It has some really good galvanic isolation, so you won't see any currents caused by ground loops. Having no cables getting in the way is really nice. You just pick it up and use it. The 40 volt input, the plus or minus 40 volt input, is really limiting, and because you don't have a standard B and C type input, means you're stuck with the one impedance and can't use 10 times probes. On the software side, apart from that issue I had with Mac OS X, Windows and Linux worked okay. Came up with the same interface as the iOS app, and what I've seen so far, the app is pretty rock solid. There's no complaints there. In terms of price, it's a little pricey, but I can see there's a lot of R&D went into it. It's a pretty solid product. Of course, Ecologic don't have the same name as other test gear companies, so of course you naturally question the asking price. If they keep producing quality products like this, then they'll go far. Would I buy one? To be honest, at that price, probably not. The only thing I can fault it on is the price, really. So anyway, that's it for the IkaScope. So before I go, there's a couple of other things that I got from the Adelaide Maker Fair last weekend. Unfortunately, this video was supposed to be published last weekend, but I ran out of time completely because I was preparing for the Maker Fair. So I got several items down there. I got the Mappy Dot from Blair, and I got this in the post, which is from Ozmaker, which is the Berry IMU, and John, who also runs another Tindie store, gave me this while I was down there. So let's crack these open and have a look at them. So the Mappy Dot is essentially a VL53 LOX time of flight range sensor, and it also contains an Atmega 328P on it. So it comes in two bits as the base board, and this is the actual Mappy Dot unit. So it's quite a nice little unit. He's managed to squeeze it all into a tiny little package. So let's solder it up, fire it up, and see how we go with it. It's always a bit tricky soldering up these smaller pitched pads, but it's doable. So Blair has provided a spot for being able to program it using ICSP. There's also external I2C pull-ups if you want to be able to put pull-ups on there. He's included it as a separate thing. What else? And also some breakout headers along here so you can put onto a breadboard. So I won't worry about using ICSP, I just want to fire it up and see what it looks like. You'll notice that he's got the same pinouts on one side as the other, and the whole idea is that this is daisy chainable, and he's developed an auto addressing scheme, so there's actually no address on the board itself, and they'll just figure out the I2C address auto magically. So for some reason I wasn't able to get Blair's Mappy Dot going, so I need to spend some time finding out why I couldn't get any readings from it. I could certainly see it. I2C scan was coming up with a response, but for some reason this was getting no response out of the Mappy Dot. That's something for a bit later on. I need to investigate a bit more. So the next one came from Ozmaker, and it's the Berry IMU. It's been around for a fair while. So this is based on several sensors, two sensors, one which is the LSM9 DSO, and there's also a barometric sensor, which is the BMP 180. So it's a nice little board as well. It also has a small header, so you can use that to interface to a Raspberry Pi if you want to. But it also can connect to Arduino and so forth. So let's solder this one up and see how this one goes. So I'm just running it on the Pi here. So that looks pretty good. It's fairly straightforward. He's got a whole lot of demo applications that just run straight away, and yeah, they function well. That's quite nice. And of course you can read the temperature and pressure from it as well. So yeah, it works quite nicely. And don't forget, this is also one of the prizes that I have in my competition. And finally, we have from another Tindie store, Tinker Electric, the Water Me Bird plant saver. So John told me this all started with his partner who kept on killing his plants, I think. And so he just made this to be able to just alert his partner when the plant needed some more water. So it's fairly simple. So it's based on an AT Tiny 85. It's all pre-programmed, so you don't need to worry about it. And it comes as a soldering kit. So let's solder this up and see how it goes. So it's quite good. He's left no doubt about what components to solder where. He's marked everything fairly clearly, so it should be really easy for anyone to be soldering this kit. I always like to have tidy resistor legs. There's no point having messy legs. So I tend to just bend them into shape. And lastly, we've got the buzzer. Then just a matter of chucking these rods in, which is a good idea, to use terminal blocks to attach it. And lastly, we just need a coin cell battery. The theory is that you press it in the state that it's going to be dry, and then it should just tweet periodically, indicating that the soil's dry. And then when it gets wet, so I'll just simulate that with holding the two contacts together, it stops tweeting. It's a pretty simple kit, and something really anyone should be able to make. There's no problem with it. Fairly clear instructions, and it's actually pretty useful too. It's one of those things that you just chuck into a pot and no one will be killing any more plants. Excellent, thanks for that, guys. So we have the Water Me Bird Plant Saver Kit, a Mappy Dot, which unfortunately, Blair, sorry about that, I couldn't get it going, but I'll, in a follow-up mailbag, I'll check it out. The Berry iMube, it's actually still connected to my Raspberry Pi. So the next one up is from Kogan. So essentially, I'm looking at a whole lot of different devices that I wanted to be able to make a little bit smarter. This is a smart sort of kettle from Kogan, fairly simple one, but I want to be able to add some Wi-Fi connectivity and a whole lot of other things, so I can actually make some fairly intelligent devices. Hopefully you'll be able to connect them up to things like Alexa or Google, and be able to say, Alexa, make me some tea, and have it all done for me. The model, it was one of the cheapest ones I could find. The reason why I got it, because most of the work's been done for me. So the way normal electric kettles work is that they have a thermoelectric strip. As it heats up to a certain point, which is boiling temperature, it'll actually cut out. So they're fairly basic, so I needed something that had a bit of smarts to begin with. Just makes the job a bit easier. So this one has a display on it, and all I want to be able to do is just interface into this. So I can, I don't know how this works. Oh yeah, there we go. And it looks like, you can adjust the temperature down. You can also set it down to 50 degrees. I'm not sure why you have something at 50 degrees, but anyway, there you go. You can adjust it and it automatically adjusts for you. 95 is the maximum, apparently. There you go. So fairly basic, but let's crack it open and see what sort of electronics are inside. Okay, so it seems I can just pull this cover off, which is handy. So I suspect I've probably got a fairly common base unit, and they've just added in some so-called smarts to it. Okay, there we have it. Nice. Fairly basic power supply. Got a relay for control, a buzzer. So what I need to do is find out, oh, that's really nice. Labelling on here, which says int buzz relay 5V ground. So this is essentially the bit that I'm interested in. Okay, so it looks like I've got an SH79F083A. Okay, so it looks like it's an 8051 based microcontroller. Very, very common in kettles, fry pan, all these sort of things. Very cheap as chips, quite literally. So there's two ways I can go about this. I can either completely replace this, or I can see if I can actually pull the code from that and reprogram it. and then get a simple ESP8266 attached to this, and then be able to control it that way. If I can't access that, then the next thing is I'll get a simple ESP32 or 8266, and there's actually space in here for really to put one of these, which will fit nicely there, and I can interact with the 8051 on board here. So just powering it up and seeing what voltages we got. Yep, so we've got 5 volts in here, which is alright, that's good. And all these other things would be relay control and temperature sensor. So excellent. So my main intent was really just to see if it was possible to interface to this. This is going to be dead easy to be able to just add a simple Wi-Fi module and be able to control it remotely from my my phone. So let's crack open the bread maker and see if we can do the same thing with that. And the last thing I got was a bread maker. I miss having homemade bread, and because I'm a celiac, I tend to, well, I can't eat bread. So this is a fairly sort of bog standard bread maker, but once again the intent is to crack this open and get access to the inside, add an ESP8266 or something else, and be able to actually control it remotely. Okay, so opening this up is pretty easy. 4 screws there, and required a bit of extra sort of prying off, but I managed to get off the control board, and that's hopefully where all the smarts are. I don't really see any smarts in there. It's just a power supply, motor, thermostat, fairly basic stuff. So this is where all the good stuff is. By doing this, I've completely avoided the warranty, which, you know, hey, that's no big drama for me, unless it stops working, and then it's a bit of a waste of money. Okay, so what do we have? It's a bit hard to read with all this conformal coating that they put on. So the conformal coating is necessary, especially if you've got mains or any sort of appliance that requires mains or is near mains. You, by actually applying a conformal coating, which is sort of like a lacquer, you can actually allow to have the board in a hostile environment. Okay, we seem to have a winner. So this is an MC804708A. This is part of the MC800 series of microcontrollers, 8-bit microcontroller. It's got 8K of onboard flash. This will be really easy to interface with. Now the question is whether this runs at 5 volts or 3.3 volts. So let's power it on and see what sort of voltage levels we are getting. And what's really nice is when the manufacturer actually provides labels on the connector. So I've got ground and VCC, so there's 4.5 volts, and there's several other voltages hanging around as well. It even says it here, there's motor, heat, and a couple of other things like ADC, ANO, voltage up. This is completely interfaceable. I can do it one of two ways. I can either completely replace this, the control board, and just interface to this, but the problem is that the MCU board has the program on how to cook the bread and monitor temperatures and so forth, or else instead I could actually just interface into that little board here. That's probably the easiest way, and I could simulate button presses on the front of the board, or else I could monitor what the chip is doing while it's running through a cooking cycle. So I think monitoring the signals backwards and forwards, it's all very doable. So that's nice. It's a very basic microcontroller. So I have the bread maker, I've got the electric kettle, and also from a previous mailbag segment I've got the electric toaster. So I'll be able to interface all those and be able to program them from my smartphone. So anyway, it'll be interesting to see how all those appliances go with a Wi-Fi module installed. If you want to be able to see those videos earlier, then you can become one of my patrons. Give all my patrons the chance to vote on upcoming videos. So all my patrons set the schedule. Sometimes I don't always get the video schedule out according to plan, but I try my best. Oh, hello, it's my second hand. What do you want? Oh, you want a tummy rub, do you? There you go. Alright, off you go. Go and have a play. Anyway, thanks for watching. See you next week.